Drive time is you time. Turn on Do Not Disturb before you leave.
Welcome. The Office of Design is excited to host this webinar today. All attendees will remain muted throughout the webinar. Please submit any questions using the Questions Dialog tool. Questions will be addressed during the presentation via the dialog box. This webinar is being recorded and posted on the Office of Design's website for future reference. You will now be placed into a listen-only mode for the remainder of this webinar. Let's get started. Next, we will quickly review the continuing education requirements and process. Continuing education credit will be offered to those who attend the live session. You must attend the entire session to be eligible for the continuing education credit. Attendees will receive their participation certificate using the email address they registered and signed into the GoToWebinar site.
Good morning, everyone. My name is Rick Jenkins. I'm the State Standard Plans Engineer in the Central Office. I'd like to welcome you to the latest edition of the Standard Plans Update Training. Today, we will go over some of the updates and revisions to the 2026-2027 Standard Plans for Road and Bridge Construction. If you're unable to attend the entire training today, or if you know someone who couldn't attend the presentation today, it will be available on our training site for those who have missed it. I'll show you a link to get to it in a minute. I am excited to announce that this year we will provide one PDH for attending for those who attend the entire presentation live. That's something that's been asked of me for the last couple years, and in the past we didn't have that option, but we worked it out this year where we will be able to provide the one PDH for those that attend the entire presentation. Here's a list of our presenters for today. Jimmy Frimmel, our Standard Plans Publication Manager, he's going to cover indexes on curb ramps, drainage, specifically end walls and sand filters, and some updates for sign supports. Ryan Gray is our Standard Plan Specialist in our group. He is our pavement markings expert, and today he's going to cover some Standard Plans updates for pavement markings. Shay Gibbs is also a Standard Plans specialist in our group. She's going to cover a few topics today: fencing, shoulder treatment, and special signs. The special signs update was a pretty big update, and we basically renamed most of the signs, changed the naming convention, and she's going to cover all of that for you. Richard Stepp is a senior Standard Plans engineer. He's going to cover barriers, guardrails, and curb and gutter. He's going to give quite a bit of information. I know he's got some great updates to give you here. Joshua Turley is a structure Standard Plans engineer in our structures office. He's going to go over some of the various structural related indexes and give you some of the updates to those specific indexes throughout this last revision cycle. As I like to do every year, I want to point out our website. You can see the website address at the top of the page. I want to point out a few of the specific links here. This link highlighted here is the current Standard Plans link. We update this every year with the current Standard Plans book, so that now this link will take you to the 2026-2027 Standard Plans. That's also where you can find the bulletin that released the Standard Plans. Here's a link to the past version of the Standard Plans. This is where you can find all versions of the Standard Plans. You can also find all of the bulletins that were released, that released these books over the years. Here's a link to our developmental standard plans. The developmental standard plans may not update every year like the standard book, but if they do, you will find them here in the developmental standard plans link. Here's a link to our CAD files or our cell library. I get this question often about asking us to send the CAD files for the certain standard plans index. Well, all of those CAD files for the standard plans are available on our website without request. They're there always. You can just go to the link here on our website and download them. Here is a link to the training website, like as I mentioned before. This is where you'll be able to find this presentation once it's complete. You can also find update trainings from past years. We are also working on some updates for FDM update training, so those will be found in this link as well. I wanted to highlight the whole review and response section here. This is where you can submit a revision if you're with FDOT. This is where you can track and see where each revision is within the process throughout the year, whether it's in internal review, industry review, or FHWA review, or if it's been approved and the reviews are complete. You can also click on each index and revision and see all the revisions. We're not going to cover everything today. We're only going to go over a few of the higher level updates that we felt were important for you to see today. And that's all I've got today. I'm excited to hear all the presentations today from our presenters. And like I mentioned, Jimmy's going to start off first. Thank you, and I hope you enjoy the presentations.
Thanks, Rick. As Rick just mentioned, my name is Jimmy Firmel, and I'm the Standard Plans Publication Manager here in the Roadway Design Office. I'm going to cover revisions to 4 of our Standard Plans indexes as part of this year's fiscal year 26-27 revision cycle. First, we'll touch on revisions to Concrete End Walls Index 430-030, where we've added a section to show both precast and cast-in-place options. Next, we'll cover multiple updates to the Under Drain Standard Plans Index 440-001, where notes have been clarified, a table of contents has been added, and a new detail has been provided for wet detention side bank filters. We'll also touch on some edits to Index 522-002, where notes have been added or moved for clarity, and typical curb ramp layouts previously included in the index removed. More on that in a moment. Finally, we'll walk through some updates to Standard Plans Index 700-101, where we've modified a note to provide additional guidance for sign placement along various multimodal paths, as well as some general housekeeping items. Here we have the red lines for Index 430-030, straight concrete end walls, single and multiple pipe. As you can see, Section A-A has been added to show both precast and cast-in-place options. This revision was requested via the State Materials Office by our industry partners from the Precast Concrete Structures Association. There were issues with the delivered product, so this addition of an alternate to hole forming and minimum beam height above the opening were included in the index. This update was signed as an approved shop drawing by the state drainage engineer. And here's a detailed look at that section A-A. Next, we have updates to Index 440-001 under drain. As you can see in the red lines, the index received a new sheet and the table of contents was updated accordingly. Note 10 was added to ensure an additional 6-inch length of geotextile is anchored under soil or coarse aggregate, and a new type VA wet assembly detail was created. Here's the completed published index with those changes incorporated. The new detail is similar to the underdrain type VA and VB, the dry assembly, but occurs along a wet pond. With new ERP stormwater quality standards, this provides designers with another tool to meet those standards. Here in the red lines for sheet 3, a majority of the changes were to clean up the index and provide consistency with terminology used in other drainage-related areas of our standards. For example, ditch or basin was changed to swale or pond in several locations. Alternative anchor locations and geotextile extensions were also added to the details. The upper limits were renamed to delineate between wet and dry applications, and type VB and V cleanout details were moved to the new sheet 4 for clarity. Here's the updated cleaner sheet 3 and the new published sheet 4. These changes all assist in clarifying the notes and details to provide designers with more options. Now for index 522-002. Not too many changes made here, just movement of some notes to consolidate all the notes onto the first sheet, with the exception of one railroad crossing note. One note was added to reinforce the requirement of a minimum 48-inch full-height curb separation between ramps where multiple ramps exist. And here is the published sheet 1. As for sheet 7, notes 1 and 2 pertaining to crosswalk markings were moved to the first sheet, as I mentioned before, while 4 examples of sidewalk curb ramp placement at curbed returns were removed from the index. This change coincides with the revision to FDM Chapter 222, where guidance and preference of curb ramp placement was provided to ensure a more site-specific design of the ramps rather than one simply selected from the standard plans. Lastly, we'll address Index 700-101, single and multi-column signs. To start, this formerly single-page index has become crowded, so an additional sheet was created to spread out the information for clarity purposes. Details and notes were retained on sheet 1, and the use cases were isolated to sheet 2. Note 7 was also modified to provide additional information for placement of signs along shared use paths and urban side paths. These notes address avoiding reduction of the accessible width of the sidewalk, providing a 4-foot and 2-foot clear area adjacent to both sides of the shared use paths and the urban side paths, respectively. More direction and guidance on these different path types was also provided in the FDOT design manual and will be identified in that update training at a later date. Here we have the newer, cleaner sheet 1 with the notes and the details, and sheet 2 of index 700-101 with the 10 use cases. This concludes my portion of the update training. Here's my contact information if you need to get in touch or have any additional questions. With that, I'll pass it along to Ryan Gray to continue with some more updates. Thank you.
Thank you, Jimmy. Hello, everyone. Welcome and thanks for attending the fiscal year 2026-2027 Standard Plans Update Training. My name is Ryan Gray, and I'm a Standard Plans Engineering Specialist here in the Roadway Design Office. Today, I'll be going over the following primary updates. Index 706-001, typical placement of raised pavement markers, where we have removed RPMs from the wheel path and the wrong way arrow. Index 711-001, pavement markings, where we have added an additional base option for tubular markers in grassed areas. And Index 711-003, interchange markings. We've added a new detail for single-lane parallel type entrance ramp without added lane, updated the wrong way arrows to be consistent with 706-001, and made changes to the channelizing lines around the gores at the collector end of ramps. Starting off with Index 706-001, typical placement of raised pavement markers, sheet 2 of 6. Here in the red line markup, we see that we removed 2 RPMs for wrong way arrow detail, updated dimension to 2'6", rotated RPMs within the arrow to match the rest of the RPMs. Here we can see the updated index with the revised RPM spacing and orientation and the 2 outermost RPMs removed from the wheel path over the arrow. This change was made in response to district requests to reduce the noise and driver disruption of traveling over the arrow, given the increased usage of these wrong-way driving countermeasures. Next is Index 711-001, Pavement Markings, Sheet 7 of 13. Here in the red line markup we have added drivable base option to Detail A, updated Notes 1 and 2. And here we see the new index with an additional Detail A and notes. This change was made due to requests from industry regarding additional attachment types for tubular markers in grassed areas. It should be noted that these attachment types are not approved for use anywhere other than non-paved areas outside of the traveled way. This change accompanies updates to the standard specifications, now allowing manufacturers with a post passing the Section 991 testing requirements to also add these base options for non-paved areas. Next up is Index 711-003, Interchange Markings, Sheet 2 of 8. Here we have the red line markup showing added single lane parallel type entrance without added lane detail. And here we have the updated index now detailing a single lane parallel type entrance without the added lane. This change was needed to reduce confusion around the markings used for entrance types when a lane is not added by the ramp. Again in Index 711-003, Interchange Markings, on Sheet 5 of 8. The markup here shows that we have just updated the wrong way arrows to match 706-001. And on the new Sheet 5, we now see the updated wrong way arrows with the revised RPM spacing to match the changes to the arrow in 706-001. Still in Index 711-003, Interchange Markings, Sheet 6 of 8. This red line is a little busy, but it shows that we deleted arrow pointers for 6-inch white lines, changed 12-inch to 8-inch, updated Note 1, added Note 2, added Detail C, added chevron markings to the gores, clarified edge of pavement details, updated the wrong way driving arrows. Here we have the updated Sheet 6 with all of the changes. And most notably, the 12-inch white lines have been changed to 8-inch to be consistent with our other gore channelization markings. The 6-inch white edge line along the gore for right-hand traffic has been changed to 8-inch as well to be consistent with MUTCD guidance regarding channelizing lines. Per the MUTCD, for traffic passing to the right of the gores at the collector end of ramps, the inside edge line adjacent to the physical gore should be a wide white line or a yellow edge line. That determination is based on the size of the gore being outlined. For smaller islands, such as what's displayed in this index, the wide channelizing line can be continued from the theoretical gore right along the physical gore all the way through the movement. For large islands, the channelizing line can be discontinued along the physical gore in favor of a standard yellow edge line. A second note has been added to this sheet as well to help reinforce the RPM color mandates for whichever option is used. Also in the notes, note number 1 has been updated to clarify the spacing and termination point of the shoulder delineators. Several other changes were made to this exhibit, including some minor cleanup and clarification of the edge of pavement details. The chevrons were restored to the theoretical gore areas since the channelizing lines are no longer 12 inches wide, and Detail C was added to clearly show those elements and measurements. Lastly, the wrong way driving errors were also updated to be consistent with the 706-001 changes. SPI updates. Given the change to 711-003, the SPI for 711-001 through 711-003 has been updated as well. The areas seen here in red are the additions. The new design guidance just reiterates what we went over on the previous slide, and the rest of the marking material types were added to the pay item table. Continuing in Index 711-003, Sheet 7 of 8, here are the red line markups showing updated wrong way arrows to match 706-001, removed edgeline markings from crosswalk areas. And finally, here we have the updated Sheet 7. As with the rest of this index, the wrong way driving arrows have been updated for consistency with 706-001. Also, a little cleanup was done to remove some extraneous edgeline markings from the exhibit where they pass through the crosswalk. And that concludes my portion of the training. Feel free to reach out with any questions concerning these specific updates to me at the address shown here. Thank you for your time today as we move on to our next presenter, Shay Gibbs.
Thanks, Ryan. Hey everyone, my name is Shay Gibbs and I'm a standard plan specialist here in the Roadway Design Office, and I've got a few more updates to share with y'all. This cycle, we did a full redevelopment of quite a few of our indexes. These are 4 of them that I'm going to focus on today. The first one being 550.001. This is our fence type A index. Along with redeveloping, we also added a new wildlife fence detail. Then I'm going to go to 550.002. This is our type B fencing. This one was just a redevelopment that we decided to do along with the fence type A. Then I'm going to go into index 570.010, shoulder sodding and turf on existing facilities. This one we worked really close with the districts on to make sure that we updated it to more current practices. And then I'm going to go into index 700.102, special sign details. This one is a very large redevelopment, which included renumbering signs, adding new signs, and deleting some of the signs that are in there. Starting off with index 550.001, type A fencing. On sheet 1, you're going to see a lot of red lines, and I'm going to kind of walk you through some of these changes. We started off by moving all notes pertaining to materials to their respective specifications, whether that be the 550 specification or the Division 3 for steel, timber, and aluminum. We also deleted a couple notes that were already covered in the specifications or already covered in the details within the index. And then because we added that new wildlife fence, we moved the farm fence notes to sheet 2 where we have a full farm fence detailed sheet. And then we also added a table of contents and a detail for fence post locations at frontage roads details. And I want to point out that we did update this one note. We used to require that the wire side be installed on one specific side of the fence, and we are changing it to allow it to be installed on either side of the fence to allow for the districts or whoever's installing it to make the decision on what's easier maintenance-wise. Here you can see the full redeveloped index. You can see a lot of the notes are gone. As you can see, a lot of the notes are gone. There's much fewer of them, only 10. You can see the new detail in our new table of contents. We're hoping this makes it a little easier to follow along the index. Going into sheet 2, you can see that we're starting our division between our farm fence and our wildlife fence. So this is our 5-foot farm fence. On this one, you can see we moved the design note to the standard plans instruction for the designer. We also rearranged the index and added a couple more details along with those notes, and you'll see that on the next slide here. It looks a lot busier, but it does cover all the details needed for a 5-foot farm fence. You'll see that we added a sheet title to make sure that it's very clear what this index sheet entails. We also added this typical fence detail at the top, which kind of aligns with the rest of the index and gives you a clear view of how the fencing is laid out. You can see that these details have a little more detail to them, a little more aesthetic details with the shading. To make it easier to understand and see, we took out some of those larger callouts and moved them into the notes. And then in terms of the dimensions of the fence post, we have it matching what you'll see in the wildlife index. And then we have our farm fence specific notes over to the left. And I also want to note that while you see the 8-foot distance on the details to the right, if you look in the typical fence detail, you'll see that there is an 8-foot typical distance, but you can go up to a 14-foot max. On sheet 3, this is just a farm fence specific detail sheet. You can kind of see where we moved the fastener and timber post and brace to the last sheet. We moved the splice details up, which you saw before, and made this more just for concrete posts and braces. And here's the new sheet for concrete posts and braces. This is, again, specifically for 5-foot farm fence. Here we have our new sheet 4. This is our new wildlife fence details. It looks very similar to our farm fence, but there are some key points I want to point out with this fence that we've added. This is a 10-foot fence instead of a 5-foot fence. It's much larger. It has a larger gauge fence fabric. It has more barbed wire along with a larger gauge barbed wire. And I also want to point out that this fence in specific is timber only. Our farm fence covers recycled plastic, concrete, timber, steel, aluminum. The wildlife fence is a timber-only fence. These details were developed with the help of District 3. They developed them when they were cleaning up from Hurricane Michael and found that these became a bigger need, which is why it got added into our indexes for all districts to have availability for it. And then our last sheet are just some more detail sheets. You can see where we brought in the timber post and brace fastener from that previous sheet. And then you have the fencing detail at a culvert that looks very similar to our typical fence details that you can see on sheets 2 and 4. But this one covers both wildlife and farm fence in the detail. Next, I'll cover Index 550002. This is our Type B fence. This one just was more of a focus on cleaning up and doing very similar things that we did to our previous index, like moving all of the materials notes to their respective Division 3 specifications, along with moving design notes to the SBI and updating some of the language to plain language, and then adding a table of contents and the same detail of the fence post at frontage roads detail like we had in Index 550001. Same thing here with sheet 2. You can just see the red lines where we move some of the design notes along with updating the language. Here's the new sheet. As you can see, all of the notes have been brought onto sheet 1 instead of being divided up into 2 sheets. There's the table of contents and the new detail. And then here you can have just the fencing details, very similar to our previous index. Sheet 2 is just some general redevelopment and cleanup. We didn't change much of anything. But here is the new sheet. You can see we kind of divided up the details into their own sections, along with making this very similar to how we have our other indexes. As I said, we moved a lot of our materials notes into the specifications. I'm going to start with specification 550, where you can see we added in the Type A wildlife fence. You can also see we added in all of the materials that are used in these fences and where to find them within the specifications. Also in this, because there is not a Division 3 that kind of fit the recycled plastic line post or the concrete post, we just put them in the 550 fencing and specification. That way they don't get lost, and since they're non-standard, this felt like a good place for them. Specification 954 is where you'll find the timber requirements. Most of those are covered in the index, but there's a couple that just fit in the specifications, like the flexural strength requirements, and then we also added in some APL requirements. The steel requirements, on the other hand, had a ton of details that got moved into the specifications. So you'll see that in 962, there is a full section for fence materials, and it breaks out into quite a few tables. So you'll see the APL requirements, the fencing fabric requirements, steel post, beams, and pipe tube, and then tie wire and barbed wire requirements. Similarly, in the aluminum, we created a table. However, it's not as many tables as with the steel requirements. It is just this one table. And then you can see in our standard plans instructions where we moved some of these designer notes needed just for the designer and not for the installation, such as where the fences are typically provided, the types of swaps you can make with the farm fence. And then you'll see our updates to our SPI 550. These are all the notes pertaining to design that we pulled out of the indexes and just moved into the instructions, making sure that they are going to be put in the plans and not just the installation details. Next, we're going to go into our Index 570010, shoulder sodding and turf on existing facilities. This one also went through a large redevelopment from requests from the districts. We were told that treatments 1 and 2 are not very commonly used, if used at all anymore. So we took those out and instead replaced them with these asphalt overlay details, shoulder widening detail, and a super elevation detail. And to assist with those, we also added a drop-off detail and a sloped sod lap detail. We also added some new general notes, which you can see here. We have a new General Note 1, which states that the existing turf may be flush with, higher than, or lower than the existing edge of pavement or paved shoulder. Trenching or mixing will be necessary when existing turf is flush with or higher than adjacent pavement. Shoulder drop-off soil will be necessary when existing turf is lower than the adjacent pavement. So you'll see this shoulder drop-off soil coming up a lot in this index now. We found that we needed something to cover the makeup soil needed to bring the dirt up to the pavement level that we need. And while Borrow covers that, sometimes that makeup soil that's used to just cover it, it wasn't covered properly really anywhere. So we established shoulder drop-off soil as a pay item and in this index and the specifications to make sure that it is understood when to use this type of soil as opposed to Borrow. And you can see that within these general notes as well. So you'll see in the new note 3, Borrow is replaced with shoulder drop-off soil, and then we'll go into general note 6, which was added. This one covers a little more for the rolled sod. When using rolled sod parallel to the roadway, begin placement at the farthest section away from the roadway in the areas to be sodded as called for in the plans. We also added note 8, which states grade to shoulder slope shown in plans or per super elevation up to the full shoulder width shown in plans. And then I'm going to go back to note 4 because I missed that one. This is where you can kind of see a little more into that shoulder drop-off soil language. Shoulder drop-off soil may be used in lieu of excavated turf and topsoil when drop-off does not exceed 6 inches. In that case, you will use the Borrow. And then here you can see this index has completely changed. We have our new details. We have our new notes. One thing I want to point out is in that pattern detail, this shows palletized sod, but we also added in a note for the minimum 3-foot sod width for rolled sod, as you do have the option to use both. We also added some language into our standard plans instructions to give a little more guidance and clarity. One of them being for shoulder drop-off soil, assume an average of 250 cubic yards per lane mile of shoulder requiring correction. Adjust as necessary based on field conditions and district experience. Include average cubic yard per lane mile of shoulder amount in the summary of earthwork design notes column. So this is just to help you with your estimation and your quantities. We also added in a little more language in terms of the sod width with the palletized sod and the rolled sod, making sure that you understand what is typical for those. And then you will see that we very specifically tell the designer to include the shoulder and sod width in the plans along with the shoulder slope. And then down in the payment, you can see we added in that brand new shoulder drop-off soil per truck measure payment item. To help with all of those new details, you can also see we added some language into the specification 570. A lot of this has to do with that new shoulder drop-off soil. It kind of helps understand the testing along with where to put it, along with the quantities. Specification 120 clarifies very specifically that testing and how if the plans indicate the use of drop-off soil, then no further testing is required. Going into index 700-102, this is our special sign details index. I wanted to start with our brand new sheet 1 because this kind of kicks off the redevelopment of this. We did go into renumbering all of our signs based on what is covered in the sign library, the traffic engineering manual, hoping that it'll make this easier to go through the index from now on. So you'll see we have our numbering convention to help with the renumbering with the FTP and new TTC signs. I'll get into that in a second. But it has the FTP or TTC, your sign type, which you can find next to that in our sign type block there, which covers regulatory, warning and advisory, motorist service, guide, recreational and cultural, miscellaneous, and then our temporary traffic control signs. It then has, you see B and C. This is kind of our size adjustment or our left and right adjustment. And then all of our new signs currently had the year of update, which would be 2025, which is this year. We also provided a few examples to make sure that that is very clear. And then you'll see our table of contents, which helps identify where you need to go within this index, considering it is a 21-page index. And then we added in a crosswalk at the end. So that way, if you go and find one of the older signs, it's very easy to find the new sign number that correlates to it. So this is our old sheet 1. Here's the red lines that shows the renumbering of the sign order. We also updated some of the radii and border dimensions per the sign shop. And then you can see down in the bottom where we have our left and right designation for FTP 603, and then FTP 601 kind of shows the size designation as well. You'll see that, I think, on another sheet. Yep, this one as well. So this one has the same renumbered signs. I want to point out down at the bottom, FTP 610, you'll see the 610, 610A, and 610B. These are because it goes from smallest to largest on size options. We also updated our new FTP 401 and 402 signs. Instead of having that half sign showing, we wanted to go ahead and show the whole sign to make it more clear what the dimensions on that sign are. And then the Turnpike advised us to remove the line in the middle of Florida for the new Florida Turnpike symbol. On the old sheet 3, this one had a couple other details added along with the renumbering. One of them being note 4, which states that the width varies on the border depending on the digits within that sign. You can see that because it states that the width on the border for the 3 or more digits is E, and then we have our different sign widths in that table below. The old one gave a very strict 7/8 border, but we wanted to make sure that it is very clear that this is an adjustable border based on the digits within it. We also added a little more clarity over to our county route markers, stating that the Series D legend numbers and letters are all uppercase. On our old sheet 8, the only thing I wanted to point out on this one was that we deleted FTP 69-06, which is our no pedestrian bicycle motor vehicles less than 5 bhp. Our old sheet 9, I added this one to show that while we have our left and right, we also have our U-turn sign, which we designated with that letter U instead of the L or the R, down at FTP 034U25. On the old sheet 10, all we did was delete this left turn yield on flashing yellow arrow. This one is already covered in the MUTCD and no longer is needed in this index because this index is very specifically Florida signs and does not cover MUTCD signs. Going into sheet 12, this was kind of what I touched on earlier. We updated all of our MOT designations to TTC designations. It's a little more current, up to date. We also deleted G20-1 and G20-2, which is our roadwork, next number of miles, and in roadwork signs, as these are also already covered in the MUTCD. We'll start with some of our newer sheets. So this is our new sheet 2. This comes right after that sheet 1 that had the tables and the table of contents. So the new sheet 2 is our regulatory signs. On this sheet, we added 3 new fender bender signs. On sheet 3, same thing, regulatory signs, but we added a few more onto this sheet, including our brand new Florida law move over for stopped emergency vehicle sign, the 2 axle vehicles only buses allowed sign, and then the 3 emergency stopping site signs. On the new sheet 4, this is also regulatory signs, but we added a new size option for our Fine 250 Max sign. On the new sheet 5, we're still in the regulatory signs, but we added some new crosswalk signs, which is FTP 02725, FTP 027A25, and FTP 02825. And then sheet 6, this is the ending of our regulatory sign type, but we added a new sign for no pedestrians or bicycles beyond gate. Sheet 7 kicks off our warning signs. This one we added a new crossing sign, a new on sidewalk sign, and a few new motorcycles use caution signs, which have a few different size options. Sheet 8 continues our warning signs, and this one covers our new prescribed burn ahead signs. Sheet 12 goes into our motorist service signs. On this one, we added 3 new share a ride sign options along with some new emergency info sign options. Sheet 14, these are our guide signs. On this one, we added a new sign. You can see it in the bottom right. It's FTP 60925, and it's a new directional highway marker sign. Sheet 17 also covers a few more guide signs, and this one covers our Amtrak signs, our Greyhound signs, and our cruise ship signs. Sheet 17 goes into our recreational and cultural signs. This one we added the 2 new Memorial Highway signs. You'll see it has the 2-line and 3-line option. And then we added our Florida Scenic Highway signs, which also have 2 options. Sheet 21 is our temporary traffic control signs. These are just the new ones that we added, which are our reduce speed, smoke ahead signs. And then you'll see other motorcycle use caution signs. I want to be very specific on these are pink signs, whereas the other ones are orange signs. One is for temporary traffic control, and one is another option for our roadway signs. And then here's just a glimpse of our crosswalk at the end of the index. This covers all the renumbering and makes sure that you know exactly where to go if you're looking at an older index compared to our newer one. Thanks, everyone. Again, my name is Shay Gibbs, and here's my contact info. Up next, you'll hear Richard Stepp. So take it away, Richard.
Thank you, Shay. Yes, my name is Richard Stepp with FDOT Central Office in Tallahassee. And for the 2026-27 Standard Plans Update Cycle, I'm primarily responsible for the following: Type K temporary concrete barrier, adjacent barrier inlets, curb and gutter barrier, concrete barrier, guardrail transitions, the post and beam bridge railings, and the larger standard of guardrail. So up first, we'll take a look at Index 102.110, Type K temporary concrete barrier, where we've basically added the compatibility for single slope barriers and then also added clarifications to our general notes. All right, so taking a look at sheet 1 for Type K temporary barriers, we've updated the note heading. So right here at the top, it just used to mention something about Thribeam. We went ahead and changed that, so now it says connection to permanent rigid barriers. And basically per the specs, anytime we're talking about rigid barriers, we're talking about concrete barriers. So that's concrete barriers or traffic railings. And then being a little bit more helpful on this topic, went ahead and referred the user to sheet 7 through 10. And that's where you'll find all those various connections to those concrete rigid barriers. And then also we've basically added a new note 1 and shifted all the other notes downwards. But this explains that in this particular index, the term concrete barrier and traffic railing can be used interchangeably. And basically those are our 2 major types of concrete rigid barriers. But here in this training, it's a good opportunity to explain the difference as they're used throughout our standard specifications. Concrete barrier is essentially the soil mounted type of barrier that goes along a roadside in general, not related to bridges. And then traffic railings typically protecting the drop-offs on a bridge and then extending onto the approach slab. So something that's on an approach slab or on a bridge is referred to as a traffic railing, and then concrete barrier is typically roadside soil-mounted barrier. Now looking to sheet 7 is the more major update that should help designers and contractors. And really, it's simply adding the compatibility with single slope permanent rigid barriers. So in recent years, new rigid barriers, new concrete barriers and traffic railing were updated to that single slope shape. And so we're starting to see those more and more in the field as something that a type K barrier will be temporarily connected to. And for that reason, we went ahead and added that into index 102.110 as another option that temporary type K barriers can be connected to. And that's just alongside all of the others. So you can see here, it's kind of the small text. But, historically, we had connections for F-shape, New Jersey shape, median style traffic railing. Went ahead and added single slope as an option for that. Previously, there was a lot of information on the heights of the barriers that you're connected to. But really, that height information isn't typically used. If you see the type of barrier, that applies to all different heights. And so we went ahead and tightened up all the notes throughout. But the main thing is just simply adding in the single slope barrier option. So the temporary type K barrier is seen here on the right in the orange rectangle, and then the single slope as the permanent traffic railing or concrete barrier is now seen here on the left. For example, single slope is currently used in the new index 521001 for concrete barrier. That's also used in index 521, 426, and 427 for traffic railing. And we're going to take a look at 521001 on upcoming portions of this training, so you'll get a feel for what the single slope barrier looks like. And so here we're showing sheet 8, essentially the same thing, reverse direction. We've added in the new single slope option to the permanent barrier as something that the type K barrier can connect to. And so there are several other sheets in this index showing the same thing. Just know that the single slope shape as a permanent barrier is now an option throughout. And so now something that's not a revision, but we have been requested to add a reminder for designers and EORs when you're basically choosing temporary barriers for your plans. And so what we've recently noticed is that some designers are adding too much information in their plans, and the standard plans instructions, the SPIs that we're looking at here, basically tell designers what not to specify, and we don't want to provide too much information. We don't want to limit the contractor on what they can do. And so basically, part of this SPI that's in the red rectangle says designers should not specify the type of temporary barrier, basically outside of the options that are shown in the standard plans. So for example, the designer should not write concrete, not write steel, not write water-filled barriers, not narrowing the contractor down to what they can use. So basically the designer would only specify what is shown in the standard plans, and for type K temporary barriers and most other barrier types that are used for most situations, the only two options are anchored and freestanding, and then that kind of narrows down what the setback distance would be depending on if you choose anchored or freestanding. When you have an anchored barrier, reduces the setback distance. And then the other type of barrier, which is something different altogether, they would activate a different standard, would be low profile barrier. So basically these are the only three options that you'd be calling for in your roadway plans. And that's anchored, freestanding, or low profile barrier. And again, this is the information that's taken directly from the standard plans instructions. So if you need help remembering that, please take a look at those SPIs. Up next, we're going to take a look at index 425.031 for adjacent barrier inlets. And so that naming convention, just to help people better understand, that basically means there's a barrier adjacent to that inlet. And this type of naming becomes even clearer when you look at the other standard indexes that are right next to it for median barrier inlet, where the inlet is basically integral with the median barrier itself, and then curb and gutter barrier inlet, where there's a curb and gutter type of barrier, and then the inlet is also integral to that as well. So for the case of 425.031, it means that there's an adjacent barrier right next to the inlet. And they say a picture's worth 1,000 words, so here you see the inlet, and it's right next to that concrete median barrier. The two are not part of the same structure, but the barrier is just immediately adjacent to that inlet. And so taking a look at this isometric view, the major change we made for this update cycle is a clarification that's coming from our drainage office. And we really wanted to emphasize that there's a 2-inch depression, also known as a warp or a transition, that's required for the stormwater collection. So this always has been required in past standards. It may have just been a little bit more obscure with the way it was listed in notes and shown on details. And so we just really wanted to bring it to the forefront. So in this isometric view, it's now clearly shown. You can see it along the vertical portion of the barrier. Once you start to go below the gutter line, the barrier face basically that gets exposed is vertical. And so now you can see this little indentation in the isometric view fairly clearly. And then it's important to note that this 2 inches is measured from the barrier gutter line, as we've highlighted. In index 521001 for concrete barrier, we highlight that gutter line in various locations very consistently all throughout that standard. So it's basically the point where the single slope barrier face that we had just been talking about comes down, and then it turns vertical as it goes beneath the surface of the finished grade. So right at that point, it touches the finished grade is considered the barrier gutter line. Now for this special case of the barrier inlet, it basically drops 2 inches below what's the normal gutter line. And the normal gutter line will always just go in a straight line. And so basically that 2 inches measured from that. So we stay consistent throughout index 425031, just like we're consistent in 521001. So now taking a look at the next page, where you can see a section view. It's essentially, they're showing the barrier gutter line. It's called out right here at the top. Then you got your clear 2-inch dimension showing where the top of the inlet falls when it kind of goes up against that barrier. And I'll just note that in the previous year standard plans version, there were a lot of other notes that were referring to some obsolete information. And so we went ahead and cleaned that up to where we're only showing this 2-inch dimension. So now it becomes very hard to miss for the contractor. And now looking at sheet 4, the same thing, all measured from the barrier gutter line. We got that 2 inches. So now no matter what type of footing detail or barrier is shown, foundation is shown, it's always shown that the inlet basically touches up against the barrier starting 2 inches below that barrier gutter line. And then last, drawing your attention to the plan views on the left side. We've clarified some of this language to make it a little more obvious what we're trying to show here. And so basically you have your indentation in the shoulder, which is basically the water collection area that leads down into the inlet. For the standard location, it's a little bit smaller. Essentially the cross slope of the roadway would be going downhill in the same direction as the cross slope in the shoulder. And so for that reason, this water inlet collection area could be a little bit smaller. And then the slope breaks to get down to that 2-inch indentation would be just a little bit smaller as compared to the super elevation high side. And so these two labels are now different. We got our standard location. We have our super elevation on the high side. On the high side of a super elevation, you basically have a cross slope that could be going uphill until it gets to the actual shoulder where it could break and then start going downhill again. So for that reason, we want a larger collection area. So now that's clearly shown here. So now you understand you have the standard location and then the super elevation on the high side. And so up next, we'll take a look at index 521001 for concrete barrier. We've added some clarifications for our dowel joint spacing. And then you could already start to see that in showing these revisions, it becomes sort of a review of what we've seen previously because these things are working together. So we went ahead and emphasized that 2-inch shoulder depression for the adjacent barrier inlet that we've discussed. And then we've also added the single slope naming convention on the first sheet to make it all tie together. And so here we are looking at sheet 1, general note 1, the very first page, and just went ahead and put in a little clarification that the standard barrier face shape is single slope right in the first line. And so again, this is one of those changes that's fairly intuitive. Most designers would just understand this to begin with. But again, it's good from a contract point of view to kind of square all these things away and have that connectivity. And so, for example, when you're looking at index 102-110, like we just talked about, with the temporary barrier is going to connect to the new modern barrier, we can just go ahead and say it's compatible with single slope. And now single slope is mentioned in this new barrier standard, just to verify that that is what we're speaking of. Also, the traffic railing that goes on bridges is actually labeled single slope traffic railing in the title of the sheet, so that one's a little bit less obscure. But concrete barrier, in addition to just obviously looking like a single slope barrier that's got one slope going down the face, just went ahead and called it out in General Note 1. That way there's never a doubt moving forward. General Note 7 is talking about dowel joints. That's also on the next slide. I'll show you what that looks like. But yeah, so speaking of General Note 7, dowel joints, we wanted to make a note now, and even though this was already stated in the past, we just clarified it even further, saying that dowel joints may not be substituted for construction joints. It's two different concepts. Construction joint is basically where you stop and start the casting of the concrete. It has to have continuous reinforcing steel going across the joint. It's different from a dowel joint that simply has dowels going across the joint. That's defined for a specific usage. So basically, General Note 7 says you can't substitute dowel joints where there needs to be a construction joint. We basically heard that some contractors were trying to take advantage of that, and they weren't understanding the difference between construction joints and dowel joints, which are listed for different usages in two different notes. So those are not the same thing. So dowel joints are only used for connecting to adjacent traffic railings or pier protection barrier. And this is a concrete barrier standard, and a traffic railing is on a bridge or approach slab, and that's something different. So yes, you use a dowel joint between those two, but you don't use a dowel joint to replace a construction joint other than the usage that's called out on sheet 2. So the other usage would be for a concrete barrier, would be for expansion mitigation in the median barriers, and that's explained on sheet 2. And so in summary, dowel joints are not to be used as construction joints. They're only to be used or explained basically for connecting to traffic railing, which is something different, or for the expansion mitigation within the spacing range that's called for. And we'll go ahead and explain that on the next sheet. And so here we've got some views of our single slope median barrier. And as we were talking about, the dowel joints are to be used for expansion and contraction of lengthy runs of concrete median barrier to allow for that expansion and contraction. And the dowel joint looks like it does here. Basically, it's a 3/4 inch wide joint, which would be different from a construction joint because there's actually a space there. And then you see that the dowel bars go across that. And so this is a specially defined type of joint. And so previously, only the maximum spacing of 100 feet was given. To assist with the expansion mitigation, the maximum would be the concern that governs. Basically had the idea that contractors would not want to use these more than they had to, so we limited the maximum size. That said, we had heard that maybe some contractors are taking advantage, and so we went ahead and rein this in a little bit. And so again, that minimum is now given to assist with preventing the misuse and violation of the minimum barrier length, which is 40 feet. And so that 40-foot minimum corresponds with the minimum barrier length of 40 feet. So in summary, there's now a clearly defined range that can't be misinterpreted where the expansion joint needs to be placed within a 40-foot spacing and a 100-foot spacing. Generally, it should be towards the high side wherever possible. All right, now shifting gears, looking at sheet 15, we again have our 2-inch depression, which is now shown for stormwater drainage per index 425-031. This should sound familiar, and so the drainage group is happy about this, just clearly showing all locations that that inlet is 2 inches below the gutter line, which is the result we should get now in the field consistently. And so again, in this slide, we highlighted the gutter line, basically the bottom of that single slope shape. And then this is where it goes vertical. Where it goes vertical on the concrete is typically where the shoulder pavement and the finished grade would be. And so that gutter line is called out consistently in all locations throughout the standard. In this case, if there happens to be an inlet there, then finished grade's a little bit lower because finished grade is the inlet itself, and that goes 2 inches below. And then also highlighted, this all ties together with index 425-031. So it all ties together nicely. Okay, so we're making good progress. 2 standards left. Up next is another pretty minor revision, but it's an excuse to talk about some larger topics and then lead into our last topic of guardrail, which is a little bit larger. So up now, we'll bring your attention to 521.404, guardrail transitions for post and beam bridge railings and basically how to connect to those things. And here we've made a small update to the downstream connection details just to better tie it into index 536001. And so here we are looking at sheet 7 for a visual of that. And so basically we're looking at the trailing end of this post and beam concrete bridge railing. If it had been on an upstream end, we'd be concerned with shielding the concrete blunt end with a little bit more robust guardrail, but because it's on the trailing end, the angle of departure of the vehicle is not expected to hit the blunt end of that concrete. And so basically we just have, instead of a long stiffness transition, just a direct connection to a Thri-beam transition panel, which is shown more clearly in 536001, which is now referenced clearly here. And so the main revision here on sheet 7 is to update that reference and ensure that it's pointing towards 536001. And then also this used to show a W-beam, which is the smaller version of the guardrail panel, sort of like what I'm pointing to up here on the right, W-beam panel, which was a smaller connection. Now it starts off with a Thri-beam connection, which is larger. And so that Thri-beam transition panel and Thri-beam terminal connector is now clearly shown as it should be. And so since we're referencing 536001, it's a good opportunity to just advertise a little bit the type of details that are shown in 536001. So it shows you the bigger picture. You can see how it connects on the downstream end. In addition to that, some recent additions we've made in recent years is to clearly show, even on a downstream end, how the guardrail continues and then tapers over for a lateral offset, depending on the type of curb and gutter situation that you happen to have. If you're connecting to a shoulder gutter section, which is down here on the right, you're going to need to transition the guardrail over laterally as it comes off of that bridge traffic railing. And so we went ahead and showed you how that taper works. And then the same thing if you're connecting to a type F curb, you're going to need to transition over to get that correct offset as it's shown in the FDM. And so we went ahead and handled that for you as well in a plan view. And so all those cases are now covered. You just have to go and take a look at index 536001. And then last but not least, we're looking at index 536001 for guardrail. This is one of our more consequential changes where we have basically removed the TL2 guardrail option. That's the recurring 12-foot 6-inch post spacing, which I will show you graphically in a minute. We've added a new connection to the 27-inch height existing guardrail, basically provided drawings for that, what had previously been given in a note. And so with that, we'll go ahead and show you those things visually. So to make all this happen, housekeeping, table of contents, sheet 3, basically we've deleted the TL2 guardrail, and then that's been replaced with the connection to existing 27-inch height guardrail, and those details were added by popular demand. And so following suit, general note 10, we removed the written description for the connection to existing 27-inch height guardrail. And so that had previously all been described in words on how to handle that connection to the existing shorter guardrail. Instead, it's now covered on sheet 3, which we'll get to in the upcoming slides towards the end of this presentation. Okay, so making it clear, this is the old previous sheet. Previous sheet 3 for low speed TL2 guardrail is removed. And again, this is that recurring 12-foot 6-inch post spacing. As you can see here, so this would be considered the normal run between posts, 12-foot 6 inches. This was added back when MGS guardrail was added in many years ago. It was thought that it could possibly be a cost-saving measure if you had a speed of 45 miles per hour or less, and so you could use a little bit less robust of a guardrail system. That said, after years and years of use, we've looked at our pay item history, discovered that there truly wasn't much of a cost savings when comparing TL2 to TL3. And so when you also consider moving forward, the vehicle fleet on our roadways is getting larger and larger. We also know that we have challenges with things like electric vehicles getting heavier, getting harder to redirect with guardrail. Basically, even TL3 MGS guardrail with double the posts is right on the threshold for being able to redirect vehicles. And so for all these considerations and knowing that there really wasn't much of a cost savings as we had originally expected, the decision was made to go ahead and remove the TL2 guardrail. And then one other advantage to removing the TL2 guardrail is the simplicity for designers and engineers. One of the major remaining questions that we were routinely asked was about compatibility between the various end treatments, TL2 and TL3, and just the more options we have tends to cause more confusion. Even if it's labeled clearly in all the standards, the different options will always add doubts and questions. So now it's going to be a lot more straightforward moving into the future. And so we will cover this pretty extensively on upcoming slides, but I just want to make the point now to note that the other low-end TL2 end connection options do remain available, but again, this recurring TL2 longitudinal barrier is removed. So I'll cover that more extensively again as we move forward. So now this is the reminder of what is the only available option now moving forward. It's basically now just referred to as general guardrail. We know that it handles TL3, but it also handles lower test levels as well by default. So the TL2 scenario is now just handled by general guardrail all the time. And so now the only guardrail type is simply referred to as general guardrail, also known as TL3 guardrail, but if you just call general guardrail, it's the only option, and so that's the one that gets used. And so along with this change, also updated the SPI to help better explain now how these different parts and pieces are used and get connected together. Really doesn't need to be the case where the TL2 connects to a TL2 or a TL3 connects to a TL3, especially going forward. Want to make the point that the different test level options are compatible so long as you're meeting the roadway's design speed requirement. So in the very beginning of the SPI, Part A, it basically explains the general guardrail is used. It's the only choice. General guardrail is considered TL3, and TL3 means all design speeds. The end treatments, such as the approach terminals and the crash cushions, still will have 2 test level requirements because this is where you can see some cost savings and also some space savings by using TL2 versus TL3. So the end treatments, again, approach terminals, crash cushions, will have a TL2, which applies to design speeds of less than or equal to 45 miles per hour. And then TL3 applies to all design speeds. And it's the same thing for the connections to rigid barriers in the standard plans. The TL2 and the TL3 options will still be there depending on the design speed of your roadway. If you happen to have less than or equal to 45 miles per hour, you could take advantage of the TL2, save some length, and use a less robust system. But for TL3, then you would use all design speeds. And then the main point of this is to kind of give a reminder in the opening paragraph that there are those different test levels to consider. General guardrail is just TL3, but all are compatible with general guardrail. So essentially now you're selecting TL2 or TL3, but only with regards to end treatments and the connections to the barrier. And then everywhere else, it's just general guardrail that connects to those TL2 or TL3 options. So pretty straightforward. Now you're just selecting TL2 or TL3 for end treatments or connections to rigid barrier, and that's it. And they all connect with general guardrail. And so now just showing you a few of the guardrail sheets and some of the revisions that are made to keep this concept clear that the TL3 and the TL2 does still apply to certain items, and it still is selected based on the design speed. And now you can see even more of that information in the standard plans to help assist the designer. So in this line where TL3 is called out and the link for that, it says general, all speeds. And then the TL2 is more of a designer option where they know that they have less than or equal to 45 miles per hour and they can save some space and call out TL2. And so that new design speed is actually included in the standard plans now and not just the FDM. It helps with a little bit of clarity to understand that. But we want to add that reminder that the contractor can only install the TL2 if it's specified that way in the plans. And it's specifically said that way in the standards. So basically the EOR, the designer, governs if TL2 is acceptable or not. The contractor can't just pick that one. And so anywhere in the standards, there's a TL2 or a TL3 option. It will say as shown in the plans. So we know that the EOR is the one that's governing that with what they put in their plans. The contractor can't just choose. Now, one thing I will say is that unless it's otherwise shown in the plans, the TL3 version, which is for all design speeds, can be substituted for a TL2, but not the other way around. So the TL2 is really the more specific option that needs to be allowed by EOR, and TL3 can almost be used anywhere at the contractor's option, unless the designer says that they can't do it for some reason. So that should be fairly intuitive. And then going to bring up this point again that regardless of if it's TL3 or TL2, these things are all compatible with general guardrail. And then you'll see throughout this standard pretty consistently, you could have a TL2 or a TL3 option, but then on the end of that, it just says general guardrail and there's only one type. So there really shouldn't be any confusion over that anymore. All right, so next on sheet 13, we're just taking a look at some more of the TL3 versus the TL2 options so that you can see how that's compatible with the general guardrail. And so here is just a reminder of what the longer TL3 approach transition connection to rigid barrier looks like. It's the more robust, it's the lengthier one. It says TL3 in the corner, so you know which one it is. Obviously, it's labeled that way in the plan and elevation, so fairly obvious. This is the more robust all design speed version. And then at the end, it says it's connected to general guardrail over here. So you know it's just regardless of what test level, you're always connecting to general guardrail. Note 1 makes it very clear that this TL3 type is installed where shown in the plans. And so again, it's that idea that the designer, the EOR basically governs this in the plans, which one gets used. So you just want to make sure to call out, TL3 is really needed for this case. And so that note really reinforces that idea where you construct the TL3 approach transition segment where it's shown in the plans. And then likewise, we're skipping to sheet 15. This is the reminder of what the shorter TL2 approach transition connection to rigid barrier looks like. And so clearly it's much shorter than what we just looked at for TL3. The TL2 is less robust for lower design speeds, meant to handle lower speed impacts for 45 miles per hour or less. And just like the TL3, note 1 says this TL2 option is installed where shown in the plans. And so again, the EOR governs. Contractor can't decide to just install TL2 because they feel like it. The EOR really has to govern that, really make that decision based on the design speed of the roadway. And now because we made sure in note 1 that that's locked in, the contractor can't choose their own based on design speed. This design speed down here that we've added to this sheet is really more for the benefit of the designer and the EOR to understand these differences in the options that they're picking. The design speed really isn't here for the contractor choice, but we went ahead, made that leap, add this information to the standard plans just to make it pretty obvious what the TL2 option is intended for and why it's there, so first-time users understand when they're making these systems fit in with their contract plans. And that said, particularly for the TL2 version, we want to emphasize that this is an option. And so TL3 would tend to be the default. TL2 is a little bit more optional, a little bit more conditional. TL3 can be used for any design speed. TL2 cannot. So we went ahead and threw the word option in there so to make it a little more obvious that this one especially needs to be purposefully selected by the EOR, by the designer. And then again, it's that point that even if it's TL2, regardless of what the design speed is, you go ahead and connect to general guardrail because general guardrail is compatible with everything. And if you notice, the 6' 3" post spacing is shown here, which is general guardrail. It's not the old larger post spacing of the TL2 guardrail. So that should be pretty clear moving forward. All right, so switching topics away from the removal of the TL2 guardrail and the way all those other parts are still compatible, we now have a new, basically a replacement sheet 3, like I said, by popular demand. Basically, this is covering the requirements of the old General Note 10, where it described in words what we show going on here. And I think for contractors, it always is a little bit simpler just to see a picture. They say a picture's worth 1,000 words, so we'll go ahead and show those details to explain, okay, you've got this existing guardrail system. Typically when something's existing or it's not what's being constructed, it's grayed out. So that's what's shown over here on the left side, keeping in mind that this isn't direction specific. The whole thing could be mirrored or similar by opposite hand. But in this case, existing's on the left And then we have our new 31-inch guardrail on the right, as it's explained. So it's obviously 4 inches taller. And the other major difference is that existing 27-inch guardrail tends to have the splices located on the post, whereas MGS guardrail, it's very important for strength that those splices are mid-span. And so that kind of removes a lot of that shearing force upon impact. And then that splice connection is more generally just handling kind of a ribbon strength force going longitudinally along the panel. And so to increase the strength of this panel lap splice, it does need to be moved out to mid-span. And so in order to transition to that mid-span splice, there are 2 options. The first one is to use the specialized 9-foot 4.5-inch panel. These are a little bit more rare for manufacturers, but they do exist. And so in order to do that, you would connect over here at your existing post location. And then because it's different from a 12-foot 6-inch panel, it basically gets you out to a mid-span panel lap splice as soon as possible while allowing you to maintain 6-foot 3-inch post spacing the entire way. And then the second option, which I'm thinking would be the most popular, but it really just depends on where you need these posts to lay out as you go downstream and upstream. But maybe the simplest option would just be to put in one post spacing that's basically a half post spacing. So 3 foot 1.5 inch called out as a half spacing. You put that one smaller post spacing in there, and then with a simple 12 foot 6-inch panel, which are the common type, you end up with a mid-span panel lap splice, and then you can repeat that pattern on and on. Here we also give the approximate height transition. Really anything over 20 feet is kind of what we're looking for, but we went ahead and called out the convenient location of where things would change from gradually increasing uphill and then stop increasing wherever you meet that lap splice. So that would be right here. And so with that, pretty straightforward. You're just increasing height linearly, and you have 2 options again, 9 foot 4.5-inch panel up here, get the mid-span panel lap splice, or put in one half post spacing. And then you got your mid-span panel lap splice. You just gradually continue uphill until you reach that 31-inch height, and then you continue on straight. And so a couple of quick notes at the bottom that the designer would be concerned with is that this height transition must occur outside of any end treatment or approach transition segments. So those things must be constructed the way they're shown on the other standard plan sheets. This should only really occur during the general guardrail run. And then there's another note below that as a reminder, and keep in mind the notes are to contractors because they're the primary users of the standard plans. But it basically says consider the post location alignment needs when selecting the option. So as I mentioned earlier, if for some reason you need these posts to fall in a certain location, depending on where you need the guardrail to end, you basically need to do that math of the recurring 6 foot 3-inch post spacing to know where that last post is going to fall. So depending on that may determine if option 1 or option 2 is shown. And honestly, a good EOR could write in the plans whether or not option 1 or option 2 is used, and then the contractor would be locked into that. So it really would be good design on the part of the EOR to understand where you need the last post to fall, and then go ahead and choose that option for the contractor. And per note 2 here, they obviously have to follow what's shown in the plans that could govern them. Okay, so last but not least, regarding our revisions for guardrail, we're looking at sheet 9 for the trailing end treatment. We've added a new note 7 to better explain this end height, which is shown up here on the upper left-hand corner. And so a more detailed explanation for the end height measurement has been given, particularly helpful for a curbed condition. So you see now on this 2 foot 1 inch dimension saying to see note 7. And I'll just start by saying that in general, the guardrail height is 2 foot 1 inches all along the general run. That's measured to the center line of the panel. For general guardrail, if it's a curb condition, the height is measured basically to the bottom of the curb where it begins to touch the asphalt. So basically like the lip of the curb. But then this dimension here on the left side, pointing to the end height, is basically showing the dimension to the 2-inch miscellaneous asphalt pavement, which would be the finished grade directly below this end treatment. So what then happens for a curb segment, if you're measuring to the miscellaneous asphalt, this end treatment would actually be a few inches taller than the typical guardrail, which is measured to the bottom of the curb. So here, you're basically measuring to the top of the curb, Over here for the general, you're measuring to the bottom. And so that is actually acceptable for this guardrail to raise up a little bit towards the end. That's the intention because we want to keep the ground struts running along the ground line. We don't want the ground to rise above the steel tube foundations. And for all these reasons, this 2-foot one does remain consistent, being raised to the 2-inch miscellaneous asphalt, even if that's raised up a little bit behind a curb. And so as a result, basically, Note 7 is saying that you measure the end height from the center line of the W-beam at post 1 to the finish grade directly below that panel, even if the finish grade is raised up because it's a raised curb condition and the finish grade behind the curb is a little bit higher than in front of the curb, you still go ahead and measure from the finish grade behind the curb. And that's going to create the end of the guardrail that's slightly higher from the continuous guardrail run. And so the second part of that Note 7 explains if the finish grade is higher for a curb condition, you transition the guardrail's height over the 25-foot length to compensate for that difference in where you measure the height of a regular guardrail versus where you measure the height for the end treatment. And so this concludes my portion of the Standard Plans Update training. Again, my name is Richard Stepp. Please reach out to me at any time if you generally have questions in the areas of lighting or roadside safety, and I'll be sure to get back to you. And currently for this training, we're answering live questions in the chat box, so be sure to get your question in there. We'll try to respond to all of those live during this training. If they do get too lengthy or too specific, we'll be sure to follow up with you and make sure that all those questions get handled. But again, please just go ahead and get those questions in the chat box. And now up next, we have our final presenter, Josh Turley with the Structures Design Office. He's going to talk to you about some of the changes made in the SDO. And so with that, I will leave you with Josh Turley. Thank you.
Hello, everyone, and welcome to the Structures portion of the Standard Plans Update training. My name is Joshua Turley. I'm the Structures Standard Plans Engineer here in the Central Office, and I'll be walking you through some of the highlights of this year's changes. This is not an exhaustive list of the changes for this year. For that, you can refer to the revision history published with the book. Today, I'll be walking you through changes to the approach slabs, the 18-inch floor to slab beam, some pre-stressed pile updates, a modification to the traffic railings, the mast arm, and the barrier side-mounted single-post sign. On the approach slab standards, the first thing we did is move the asterisk note to a proper set of numbered notes. All of this red here, most of this red is just see the notes. However, the main thing we did in this standard is increase the tolerance for the embed of the retaining wall into the coping. Zooming in here, you can see in the green box that we changed the 3-inch minimum from the top of the wall to the underside of the coping to 1 inch for MSE walls. In the blue box, we have relaxed the minimum embed to 2 inches instead of the 9. The reason for this is that MSE walls come in precast panels, and when they build the wall, they are given an expected wall settlement amount. If or when there is less settlement than anticipated, the top of the wall elevation ends up being too high. The contractor then has to come back in and saw cut all the top panels to achieve the correct elevation. By allowing up to 2 more inches of embedment of the wall into the coping, if the settlement doesn't occur, then the time-consuming process of saw cutting is eliminated, along with its inherent risk to personnel. The first thing we did in 450-453, the 18-inch floor to slab beam standard, is we added hook bars in the optional exterior beam section, which you can see in the blue box. We did this because in the current detailing, in the top left corner, there's a chunk of unreinforced concrete. The next thing we did was increase the length of the 5Z bars. While doing some updates and checks, we found that for this FSB, it experiences increased tensile stresses at the beam ends during the release of the pre-stressing strands, particularly in longer spans where more bottom strands are required. To improve resistance to these stresses and to mitigate the risk of cracking, We extended the length of the existing 5 Z-bars to develop past the critical cross-section location from the beam end. For 455/30, the 30-inch square pre-stressed concrete pile standard, we tightened the pitch of the spiral tie spacing. There has been some vertical cracking observed in hollow core pre-stressed concrete piles, including this pile. In an effort to try to reduce the chances and effects of this cracking, we have decreased the tie spacing. We did the same thing in 455/31, the 30-inch square pre-stressed concrete pile with high moment capacity, and also the 455/60 60-inch pre-stressed concrete cylinder pile. For the 521/422 traffic railing standard, we added the option of a mortar plug at intermediate joints. Contractors found that the pre-cured silicone sealant was costly, time-consuming, and sometimes difficult to apply. The mortar plug accomplishes the same purpose, but with ready materials that can be applied during forming or shortly thereafter. We've added this similar option to all relevant bridge traffic railing standards. The 32-inch vertical shape, the 36-inch median single slope, the regular 36-inch single slope, the 42-inch single slope, the noise wall traffic barrier, the concrete parapet with pedestrian or bicycle bullet railing, and finally the 42-inch concrete pedestrian or bicycle railing. For 63010, the conduit detail standard, we set a height limitation for the conduit in the traffic railing to be a max of 1 foot 6 inches above the coping. You can see this max elevation indicated in these elevations. And finally, in this elevation. We did this because, as we will see in Standard 712, sometimes attachments are added to the traffic railing, and the anchors for these attachments can conflict with the conduit, and it's difficult to ascertain the exact location of the conduit in the traffic railing once it's constructed. If the standard is followed, then by limiting the area where the conduit can be, we know that there is a safe area to add anchors. For standard 649/31 mast arm assemblies, we moved the weep hole closer to the pole and we enlarged it from 1/2 inch to 3/4 inch. The reason for this is that water can collect inside the arm, and the arm starts out at the connection with a slight upward angle. This creates a little pocket between the weep hole and the pole where water can pond. By moving the weep hole closer to the pole, we mitigate the possibility of this ponding. For 712 single post sign support barrier side mounted, we raised the mounting hardware, including the anchors, up higher on the railing. This was to avoid potential conflicts with conduit. When they install these anchor bolts, it's very difficult to make sure you aren't drilling into the conduit in the rail. This adjustment, together with the max elevation that we saw before, that we set on the conduit location, is intended to mitigate this issue. Here is the enlarged new detail. Notice that we centered the plate on the jog in the face of the railing, and we used double hex nuts as a form of shim on the bottom anchors. And that's all I have for you today, guys. Thanks for following along with me. I appreciate your time. As always, you can contact me with any questions or concerns, or send in any ideas or suggestions for improvements to the standards. Publishing this book successfully is a joint effort between us here in Central Office and those of you out there in the trenches designing and building these things for the great people of Florida. You can contact me with feedback at the email or the phone number above. And again, thank you, and I'll see you next time.
Thank you, everyone, for the presentations.
Just a reminder, this training will be posted to our design training site within the next few weeks. If we did not get to your question today, we will respond with an email to the address you registered with. Once again, here is all of our contact information on one slide. Feel free to reach out if you have any further questions. Thank you again for attending our annual Standard Plans Update training. Goodbye.